Good morning, friends. This is Professor a.k.chaubey. Professor Chaubey's physics class under the heading Physics Made Simplest. Today I am going to solve some problems. What we have done so far, the AC circuits and DC circuits, I have done some problem before time also. So now today I will be doing some problems involving AC circuits. Thus I have given one problem here. A coil having resistance of 7 ohm and inductance 31.8 millihenry is connected to a 230 volt and 50 hertz supply. Calculate current, phase angle, power factor and power consumed. So this is a simple LCR circuit involved in which we have a coil has got resistance. So this is not separate resistance. The resistance of coil, it means it is a RL circuit, LR circuit you can say. So this is a 7 ohm resistance and this coil is 31.8 millihenry. So this coil connected to, this is RL circuit, connected to a source of say 230 volt and 50 hertz frequency. So find out current in the circuit, find out phase angle in the current and voltage, find out power factor and find out power consumed. So this is simple circuit. Now you have to do this. So what is the reactance, inductive reactance of the coil? That we have to calculate. XL is equal to, what is that? Twice pi F, that is omega L, twice pi FL or omega L. So you calculate this. So this is twice pi 2 into 3.14, F is 50 hertz and L is 31.8 millihenry. So we will make Henry. 31.8 into 10 to the power minus 3 Henry. So we must use everything in the proper units, otherwise your answer will be wrong. So this is millihenry, so convert it into Henry. Multiply this total, the XL value is, if I multiply, it is 10 ohm, means XL, that is inductive reactance. This is called inductive reactance. It is 10 ohm. And impedance, we know impedance Z is equal to, involving R and X, L, R square plus XL square and under root of this 1 by 2. This we know is the impedance. So R square means 7 ohm square. So this becomes 7 square plus XL is 10 ohm, 10 square and then this under root. Find out this. This will be impedance 12.2 ohm. Calculate this. 12.2 ohm. So I have done this problem. Then we can get the current. Current in the circuit. What will be current in the circuit? That is IV EV over Z. That is average current or RMS value. So IV will be EV over Z. EB is 230 volt, Z is 12.2. So IV current will be 18.85 ampere. Now what else? Power factor and power consumed. power factor, you know, is power factor as defined we define as tan phi. We calculate tan phi. Phi is the phase angle. So first we get tan phi, then we get phi, then we get power factor which is cosine phi. So tan phi is equal to XL over R. So XL is 10, R is 7 ohm. So this is tan phi. Tan phi is, you can calculate. So phi will be, from this you can find out tan phi is this. So phi will be tangent inverse of 10 by 7. So this you can use the table, and it is 55 degree lagging or lag behind. Now this is the phi, but power factor is defined as the cos phi. That is from the power equation. Power factor cosine phi. Phi is this 55. So cos 55. That is the power factor. And 0.5, this will be 0.573. This is also means lagging behind. So what is the power consumed? What is the power consumed? Well, power consumed is P is equal to EV IB cos phi by definition. So P is EV is 230, IB we have calculated 18.85, and cosine 55 means, so cosine 55. So this means 230 into 18.85 into cos 55 means 0.573. So this factor, power factor, P will be equal to 2484.24 units will be watt. You multiply this and that. So that is the power factor, or power consumed. So you must do problems like this involving RL circuit, RC circuit, RLC circuits. So now we do second problem. Well, second problem is a choke coil takes a current of 2.5 ampere when connected to 250 volt 50 hertz supply. So this is AC supply, 250 volt, its voltage, that is the RMS value, and 50 hertz is the frequency, and consumes 400 watt power. So power consumed is 400 watt. Now find the power factor, number 2 resistance of the coil, and number 3 inductance of the coil. So this is the problem. Well, just you take the earlier, just we have done first problem, similar way we do the power consumed. E V I V cos phi. So power factor cos phi is equal to power factor cos phi is equal to P over EVIV. So that we can get cos phi is equal to 400 power P EV over IV, and that is 250 volt, and current 2.5 ampere. So 250 volt into 2.5. So this you can calculate 0.64. It is lagging because it is inductance RL circuit. In RC circuit it leads, here lags behind. So this is the power field cosine phi. So Z impedance is equal to EV over IV. So impedance of the circuit you can get 250 over 2.5. So you got the impedance equal to 100. Then R is equal to, you know, from the triangle, impedance triangle, R, L and Z. So that is the impedance, you know, Z, L, R, phi. So from this, cosine phi is based upon hypotenuse. R over Z is cosine phi. So you know R, Z cosine phi. So you know R is Z cosine phi from this triangle. So that is R resistance of the circuit is Z. So Z is 100 into cos phi. Cos phi is 0.64. So this is 64 ohm. R is 64 ohm. Now XL is equal to under root Z square minus R square. So that you can calculate. Under root Z square means 100 square minus R 64. So this you can find out. The value of this will be 76.84. So XL is also known. Now we know XL is given as 2 pi f L is the XL, 2 pi f L. 2 pi f L. So that is, you can find out the value of L. That is L is equal to XL over 2 pi f. So this will be 76.84 XL 2 into 3.14 into 50. So just you can find out. L will be 2.245. Henry. So inductance is known, coil inductance is known, resistance is known, power factor is known, all. So we have answer of 1, power factor, and then second resistance of the coil, R second, and then the inductance of the coil. this. So all the three answers are now known. In this way, one can do as many problems as possible. So we have now another problem. This problem is now problem involving resistance and capacitance. See, a 10 ohm resistor, this is 10 ohm resistor, and 400 microfarad condenser capacitor are connected in series to a 60 volt sinusoidal supply. It is sine wave, 60 volt RMS value of the voltage. Frequency 60 volt sinusoidal supply. The circuit current is 5 ampere. Current flowing is 5 ampere. Calculate the supply frequency and phase angle. So we have to find out the frequency f and the phase angle phi. So this is the problem. I have shown this problem in diagram. This is diagram that this is the supply voltage and connected to R and C. The value is given here. The voltage here is VR and the voltage here is VC. And current is 5 ampere. This is the phasor diagram. That 50 volt, this is the one vector representing the VR, and this is the perpendicular BC. There is a voltage across capacitor, where C is 400 microfarad. And this is the current vector, IB. And this is the angle, phase angle phi, that we have to find out. So what we do? Voltage across R, we find out. What the voltage across R here? Current into resistance. Current we know is 5 ampere. R is 10. So IR, 5 into 10. So that is the voltage across resistance. That is the 50 ohm. R is now 50 ohm. What else? What is the VC? We know the VR, we know the V, so what is the VC? We can find out. VC will be now under root of 60 square from the voltage diagram, voltage triangle. 60 square minus, this is square, minus voltage here, we will get here, 50 square. And this under root. So this will be how much? 33.17. Volt. What else? XC. XC is equal to VC over I, and VC is 33.17. I is 5 ampere. So we get XC is equal to 6.634. Oh, XC is known. So now what else we have to calculate? We have to calculate the supply frequency. F is equal to 1 over 2 pi C and XC. Because this is XC is omega C, 1 over omega C. So this is omega. 2 pi F is omega and C here. So XC is 1 over 2 pi FC. So from that we get F is equal to this value. So F will be equal to proper unit should be 2 pi 2 into 3.14 into C, 400 microfarad, 400 into 10 to the power minus 6. So 400, it will go 10 to the power 6 here. C. And what is XC? XC is 6.634. So this we can calculate F. F will be of course 60 hertz. So F is known. Now what else? Phi, tangent phi, power factor. Frequency is the phase angle. That is from power factor you can get that. Tan phi from the triangle here. BC over VR. Tan phi is BC over VR. Equal to 33.17 upon 50 VR. So that you will get phi is equal to 33.17. This is degree and this is lead. Because a plus value. Leading, current leading. Current is here, voltage is this vector is here, E. So current is leading in that. In the inductance circuit, current is lagging because inductance opposes the growth of the current, Lange's law. In the capacitance circuit, current is leading. So current is here, vector, voltage is here. So this much angle phi leading. So this gives you another problem. Like this, we must do some problems, some more problems. So friends, when we meet next time, I propose to start some new topic. And I want to stop today here. Thank you very much.